Hey everyone, Norm from Tested here, and once again,
Jen from Tested.
And Jen is back with another amazing laser cutting project. I'm so glad you're able to work on one so soon after your last one.
Yeah, it's a quick turnaround. This one's a winter themed sort of snow globe thing. And this one is in partnership with Glowforge that makes a desktop laser cutter that I've got. Norm has one too. I did a haunted house kit for Halloween and that went super well. That was featured in their catalog. And so they reached out to do a special design for their holiday launch.
Awesome. So this is actually a design that people right now, if you haven't Glowforge, you can actually click the link below and find this. So it's all prepared, ready, instructions, and it's more than just a kit to put together because you have lights and other features that you can do with it.
Yeah, there's a lot of fun different elements of this. And as you can see, I went through a whole prototyping process. So even if you don't have a Glowforge, hopefully this will give you some ideas for design for laser cutting.
That's one of my favorite parts of doing these videos with you, Jen, is picking your brain about your design process. Because every project you do is kind of you step into a new territory, you learn something new, we learn something new as you go through it. So where do you want to begin with your prototypes?
Yeah, well, I mean, I guess the concept of a snow globe, right? Like technically it's a spherical shape. So
yes.
how do you get a spherical shape and make that register in flat, 2.5D essentially. So I had this idea of like sort of a stack up, so there'd be space in between each of the layers. And I knew I wanted to use light, so we've got some edge-lit acrylic going on.
Mm-hmm.
And the basic structure is it's a central base, and that's what hides the LEDs underneath. And then each of these little panels slots into the top, and the acrylic ones go all the way down to the LEDs, so you get that nice edge lighting through all of the sort of etched details.
And dimensionality in how far the panels are apart, how many layers, the materials you're using, not just sandwiched by acrylic, but also acrylic in the middle as well. All of that works to give you dimensionality.
Yeah, exactly. Like how can you create depth with flat shapes? It's almost kind of like a theatrical like layers as you're looking into a set to create that illusion of depth, even though they're just sort of like backdrops and flats.
When starting with this, and I see your prototypes, do you think of the globe, the top part, as the thing that you size first, and everything gets sized around that, or the base here?
So I started off with, I was really trying to get this with like an off-the-shelf light that you could just plug in. So I had these little LED puck lights, and I built the base around that dimension. So I was really trying to get that to fit. But what I quickly realized is that as the globe sort of tapers in, the actual space where the edge lighting is going to happen, the light wasn't getting enough. It wasn't bright enough, and it wasn't enough of a light spill to really illuminate this. So I got rid of the puck light idea, but this was my original like shape of the base was going to be dictated by that, and then figure out how much real estate I had to work with. So I did a couple versions of that with with cardboard and with some plywood and acrylic. Once I decided that I wanted to go up in scale, then I started thinking about, okay, well, I'll just do LED strips underneath, and how can I get those to shine up all the way into the whole globe?
And the strips are aligned to where these panels are, so that's how you get that edge-lit look. That's like this funny attribute with acrylic, and you've seen acrylic signs, but if you have light shine through and you cut it with a laser cutter, it actually illuminates the etching that's in the acrylic.
Yeah, so that it maintains its transparency on any part that's not etched, but wherever you have those etching details, you can get the light to diffuse in there and also around the very edge of it, so you get that nice little glow. Especially when it's dark, you can see the kind of halo of the globe itself.
I'm so curious as we're gonna disassemble, and we're gonna put one together, because that's a really interesting, like where you have it preset is where those LED strips just need to be perfectly aligned.
Exactly, yeah.
Okay, and then what next?
So from these versions, then I started figuring out my scene details. So this was my first kind of like cardboard version. You can see like all the different layers, figuring out how as you're looking at the scene, because you want to be able to kind of move around and see different aspects of it. So seeing how the layers sort of like occlude over top of each other. So when I'm working on it in Illustrator, I like to work a lot with transparency. So my version of this, my design in Illustrator is like 10 layers deep of partially translucent. So I can see all of the layers and how it's going to look when they're stacked together.
But Illustrator is still a essentially 2D tool, even though you have layers, you don't get the real parallax until you're actually putting it together. So the actual distance between your panels is an important thing. Some is perfectly You want to be right against each other. You want some to, it's not just evenly spaced, I guess.
Exactly, yeah. And playing around with that spacing. One thing I did for the centerpiece with the little house is these ones are all sandwiched together. So I've got to create the lights for the windows and the smoke. That's all edge-lit acrylic, but it's sandwiched behind. So you get, typically when you see edge-lit acrylic, you want to be able to see through it. But in this case, I hid the clear part with the plywood, so you basically just get that illumination from behind.
It reminds me of some model kits, like some Bandai model kits I've seen in the past, as opposed to using like fiber optic lights that you illuminate the windows. They just have a sheet of acrylic, and the acrylic, using that same edge-lit, idea, is a way of dispersing light and creating, as opposed to having individual lights.
Right.
And so you're doing the exact same thing here. I love that.
Yeah, because in the past, most of my diorama kits, there's actual light behind. So like if there's windows, the light is behind it, illuminating it. But in this case, all the light's coming from the base, and it's just diffusing and refracting up through that acrylic.
But you got to make sure that where you want there to be a quote-unquote light, there's etching there.
Yeah.
Because that's where it'll catch the dispersal.
Yeah, and one thing I learned actually in this project that I kind of knew but I hadn't tested it is wherever, so the light will diffuse through the acrylic up until the point where there's a right angle. So if you look closely where the top of the smoke is, there's actually no light in the top of the smoke, and that's because the light's coming up, it's coming through all of these areas, but it can't turn that corner. Like it can't refract.
It's not a real fiber optic.
Yeah, exactly. So like this part actually doesn't illuminate. And it works for the globes because they sort of, balloon out around that and the light can spill into there. But that was something I learned. I was like trying to figure out how I could get the edge of that to light up, and there's just no way geometrically that the light will bend around that turn.
Again, it's a thing that you can't figure out in Illustrator.
Nope.
You have to build it, the actual tapering of the physics of the light bouncing around. Okay, and then so you have your layers, you're sandwiched with acrylic, you have your prototype here, which is beautiful. I don't think we talked about how you actually, did the actual design of these trees and the scene here. Can you talk about that process?
Yeah, so I've worked in Illustrator mostly for laser cutting, and what I do is I have a drawing tablet and I use like a paintbrush tool, and I actually just kind of like paint the shapes in there, and then I expand the paintbrush so that it becomes a vector. So as opposed to being, all these like brush strokes, I'll expand the shape and then it'll just be this outline. So it's the silhouette of these shapes. But yeah, I wanted to kind of like painterly, it's vectors, but I wanted to have kind of a painterly look. So the trees have these like, swooping kind of edges. And then, all the little details for the house are stacked up, but there's also some surface etching on there as well to give a little bit more dimension.
It's a combination of the hand-drawn aspect, because you have your beautiful sketchbook, of course, that you do all your initial ideation on, and all of that aesthetic makes its way into the final product. One part I want to call out, because I'm looking at the difference between like this prototype and what comes next in your final, is even as you're drawing a scene, I see on your prototype, you maybe like had a circle as your framing element, and you use, I presume, like some type of the path tool to basically carve it out. But with your final ones, you actually have like curved edge detail. So it still fits within the confines of the circle, but it's not like a hard edge.
Yeah.
I love that.
I went through a couple different versions, because this one, if you look at the side, there's no, they kind of just end where the edge of the globe is. But what I realized is when you look at it from the side, you don't get the full sort of immersion in that scene. You're just seeing like it just ends. It just stops there.
Right.
So I knew I wanted to have kind of an arch that would go across the top. And so when you look at this one from the side, it fills out the side of the globe. So if you were to look at this from all angles, it's got the geometry continues. But yeah, I liked having the kind of like that tree branch look to the edges, so it's not just a flat circle edge.
It's very thoughtful.
Thanks.
Okay, so this cardboard prototype, which I hope you keep all of your cardboard prototypes, because they're little pieces of art into themselves, goes then to, I assume, this, which is with their proof grade material.
Yeah. So I prototype everything after cardboard, then I move on to just basic Baltic birch because it's inexpensive, and I can mainly get the thickness because it's pretty similar. Glowforge makes a proof grade plywood and acrylic, which is like a super nice finish. The biggest thing is that it's really uniform. So from one sheet to the next, you're not going to get any variations, which you do get with the the Baltic birch plywood. And the tolerances are just a little bit different. So I'll make it in the Baltic birch, and then I've got, I run a bunch of tolerance tests. So I'll figure out, okay, so what's the tolerance between the walnut ply and the maple ply? And I'll make a whole bunch of little joints and test the dimensions and dial it in so that the pieces that are in different materials will snap together perfectly.
And speaking of joinery, that's always an interesting topic when it comes to these laser cut assemblies. Here, you need perfect tolerances so you have no wobble with your layers, but even the design of the base, there are so many different options, right? We've seen laser cut designs that were more like when you want a spherical or like a circular design, like stacked sheets. And I see some stacked layers here, but you also went with panels.
Yeah. Yeah, and we talked about that because I was like brainstorming the design idea with you, and I was like, you know, the base should be a circle, but I don't know how I feel about the perfect like stack up of material. It just doesn't have the same look. So we were talking about these kind of like facets. So the base ended up being an octagon, so that you've got panels that describe a circle, but you can get those straight up and down, those flat pieces. Yeah, that's the me solving for how that was going to fit together.
But even the panels here are multi-layered. Or is this multi-layered or is this one panel?
This one is scored, but the idea with this was that there would be an inset behind it. So it's got a little bit of that like molding like you would see on a door or something.
That I think was a revelation for this. And it's hugely inspired by some of the other laser cutter designers that we've seen who use, when they join, non-90 degree angles, right? You're gonna get some exposed faceting, but by covering it or making with an oversized panel or something, you can hide that.
Yeah, how do you hide the fact that this is made out of flat material with a specific dimension? On this version, you can see I had the panels on the outside, so they were like.
Oh, okay.
But then I thought, oh, it'd look cooler if they were set behind. So these little score outlines ended up being the placement, and you'll see when we put it together. So the inset panels go behind it and create that kind of like molding effect.
Would look like little picture frames.
Exactly,
right?
Yeah.
Oh, well, let's go put one together.
Yeah.
Because I have more questions, but I'm sure much of that will be revealed as we assemble one.
Yeah.
Okay, Jen, so we have all the materials laid out and your pre-cut pieces. So when people get the file, how many sheets of material they're using?
So this is 3 sheets of proof grade. I've got walnut plywood, maple plywood, and clear acrylic, all 1/8 of an inch. And these are specifically designed for that material. So when you get the files, the settings are dialed in exactly. The sheet layout is fully optimized to fit exactly on one sheet without wasting any material. So everything's dialed in specifically for the proof grade.
And it's not just with laser cutting settings. I think as a designer, you're also kind of adjusting how much you can pack into a sheet to maximize the sheet.
Totally.
Because I noticed in your prototypes, there's a smaller version here, but the difference between a smaller version and this bigger version could be the difference between 2 more sheets of material.
Oh, absolutely. Yeah. As soon as you start scaling up, especially because a lot of these are big round shapes. So wherever possible, I tried to like nest pieces inside of other ones, but there's only, once you start scaling up, the real estate of material you're using increases pretty quickly.
I noticed a lot of tabs, so joinery, right, snap fit, but we do have some glue, so glue is required for a few pieces here?
Yeah, just a few pieces, mostly where there's like the inset panels or there's like stacking up of layers, but all of the actual physical joinery is with snap fit joints for the most part. I'm really getting into this like engineering, getting the perfect tolerance where the parts can snap in without too much, you don't have to force it, but it'll click into place and it's just like, okay, now it holds.
And lighting, of course, this is designed to be internally lit, although that's technically, I guess, an optional thing. And we'll talk about these fun LED lights when we get to that part. So what's your first step?
Well, I've got all the parts. These all come off the Glowforge as is. I peeled all the, protective paper off, which takes a little while. And the first thing I want to do is to build these little side panels. So let's just like knoll these. And each side panel has a sort of an outside and an inset panel. So it's pretty clear how these go like that.
And this is 8 sets of panels because it's basically an octagonal arrangement, but not evenly sized. So you have wider panels and shorter panels.
Yeah, and one thing I figured out with the design was like if you look at the front, this, basically I just pushed the front face of the octagon back a little bit because I wanted to have a wider panel here. If folks want to customize, they can etch text or design on here. And the smaller side panels here allow for that. And then the top of this is recessed as well. So like the bottom comes out as a full circle, but it's easier to view with that top cut off.
Well, I think also aesthetically, it has a little more of that. I look at this like that French, old 16th century look to it.
Totally.
With some of those narrower panels. Okay, so we're gonna get these 8 sets out, and I noticed that there's some scoring also on there.
Yep, and that's just a guide for the placement. I try, like when I think about making these as a kit, I try to make everything as like obvious as possible, so I don't necessarily have to explain like, yes, this is exactly where that goes. Like there's an outline, you just glue it right onto the outline.
Okay, so we're gonna be gluing 8 panels here.
So these are all the side panels. Now we are going to assemble the base, so the very bottom of the platform. And there's a little bit of engineering involved here because each of these side panels, in order to get them to snap fit, there's a tiny, tiny little barb, just like a few thou that flares out. So it'll go through the material, and then below the material, there's just like a tiny little, like a barb that sticks.
Like a flange.
Exactly, yeah.
It's not perfectly vertical. It sticks out to basically clip in.
Exactly, yeah. So when you press that, it'll push just past the barbs, and then you'll hear it snap into place. And that's what I'm looking for. But in order to get that to work, the barb has to come out through the other side of the material. So I needed to sort of float that layer. So there's a spacer in here, which both gives me some height for the LEDs to sit on top of there, and then also the barbs can go through and have space underneath of them.
And I found in the past, I've just stacked sheets, and I'll just say, okay, my peg is going to be the length of 2 sheets if I'm putting that through. But even if I have my kerf right, I get a little bit of wobble.
Yeah.
Right. With the barb here, things are locked pretty tight.
Yeah, and it'll have a little bit of give because when we go to put that top piece on, we want to be able to, there's so many points of registration that have to line up. So it has a little bit, but not too much. These will pretty much like, you'll have to pull to get them out. And that nice positive grab. So what we'll do is to glue this one onto here. And again, there's scored outlines all the way around, so we can figure that out. Thank you. We can figure that out for placement.
And of course, we're using just our standard CA glue accelerator, and the pro tip that Kate Sabaker had introduced to us was using the tiniest little dropper.
So brilliant.
The capillary effect of the CA kicker is enough.
Yeah, so much less likely to get glue all over your hands too. All right, so this is my spacer, and then I'm gonna go ahead and put this one on top to float. And same thing, so each layer has score lines on it so that you can figure out exactly where to place it. And then we can go ahead and start putting in the side panels. So this is obviously the front because this is the big one. So the barbs are going to go down into these slots and then snap into place. There we go.
That's satisfying. Wow, that's satisfying.
Yeah, I was like, oh, maybe it's not going to work. I checked all my tolerances. I have tons and tons of little tolerance tests of these joints from like maple to walnut and walnut to walnut because the materials are just slightly different thicknesses. So you want to get that slot to be as tight as possible and the barbs to be as small as you can get. So it'll get that grab, but you don't have to like really force it. Right. Cool. So now for the LEDs, I went through a couple different tests for this. So initially I had that puck light that I was going to use, but I found these CUB LEDs, and I learned about these from you all. I tested. This is chip on board?
Chip on board, it's what it stands for. They come in a bunch of different colors, mostly single colors, so green, red, blue, warm white. But unlike your traditional LEDs where you may see the exposed diode, it's all hidden under this nice diffuse panel, and they're more tightly packed. So you can see every place where there's a marker here is where you can cut it to length, so you can get much more precise cutouts.
Yeah.
You can't you're left with this exposed contact, but because they're hidden here, they're actually really perfect for this type of arrangement.
Yeah, I also liked, when I was trying with the SMD LEDs, the individual pixel ones, when you want to cut it to a specific length, sometimes the pixel falls not where you want it to fall, but with these, the light is pretty much continuous. So wherever you cut it, you're still going to get light the whole length of it.
Yep.
So what we're going to do, and this might actually have been easier to do before we put the side panels on, but we're just going to create like a little S shape. So we can use one continuous panel, basically, trim it, and then we'll snake the LED strip so that it goes in one direction, and then the other direction, and then the other direction, and comes out the back. So that's most of the base. Now we're going to start to put the top pieces on that will receive all of the scene elements.
So those must be
Yep.
these pieces here.
Yep. And the way that I figured this out is it's basically a series of slots and another stack up of slots underneath. And the reason for that is all of the scenery will snap fit into place, but that 1/8 inch of thickness is not a whole lot of grab, so that because they're really tall, they want to sort of wobble. So by adding a couple of extra pieces, there's enough dimension there to keep them from kind of moving around too much.
And it goes back to what I mentioned about these panels where you said you wanted a little bit of give here because there's so much registration.
Yeah.
So as a designer, you got to figure out the places where you do want to leave some give for actually assembly, but places where you don't want it for the final finish.
Exactly, exactly. So making this easier for people. So speaking of making things easier, one thing I did, and we talked about this before, like if you were to line these up and the slots were just ever so slightly off.
Just even like half a degree.
You're going to be pretty frustrated because they'll be glued together, the pieces are not going to fit through, and you're basically going to be stuck. So I did this little notch here, which allows you to then register these on the base. So there's a score mark here that matches that little notch. So that was just like one little feature that I was like, because otherwise it's just a circle.
Yeah.
So the orientation wouldn't be obvious, but that little notch hopefully will make this easy. So I'm just going to glue these carefully to the base here. And if you look really, really closely, I'll wait till that glue sort of sets, the width side to side of the slots is a little bit wider on these pieces.
Yeah.
That's so that the barb can go through and those flanges will have space to clear.
So use the outer registration, don't use the internal holes because they're actually a different width.
Exactly, exactly. All things that like I cut it one way and I was like, oh right, obviously the barbs aren't going to clear because they have to go through all that material.
This process of discovery is the most rewarding part. It's also the most frustrating part, but then becomes the most satisfying part because you're not just designing for yourself, you're designing for people out there to be able to replicate an assembly.
Like if I was doing this for myself, I would just take out a file and file them to make them fit. But I was like, no, other people have to make this, so I have to solve for this. So this is the final sort of top stack up. So we've got three layers here that are gonna receive all of the scene pieces. And this is probably the trickiest part of the whole thing. We're just gonna line up the top here with the base. So there's a lot of different points of registration that have to line up. And I'm just gonna kind of wiggle it into place. So we've got a couple here. And that's why for this part, it was important that these would all have a little bit of give so that you could slide them into place.
And you don't have the barb on the top peg, only the lower peg.
Exactly.
Because gravity helps here, you're press fitting, and you can also dab glue in after the fact.
So that went together pretty easily, so you can see these all connected.
Yeah. And you can remove it for maintenance.
Yep. Yeah, if you need to, you totally could. And then I've been in the habit of hiding all of my joinery, so I've got two panels here that go on top that will hide all of those. So you could just glue, like if you don't put any glue on top of those tabs, you would be able to remove the whole top. All right, so yeah, there's the whole base. I was very pleased with how it's nice and solid, all the joints are hidden, like it came out pretty well and it looks so nice in the proof grade walnut.
Yeah. Every time I look at this, I think these are like picture frames.
Yeah.
There need to be little scenes here. And because you can import images or other graphics, you can etch whatever you want on those panels before you do an assembly to make it more your own.
Totally. you mentioned that to me, and I took your idea and ran with it. So I made a little sample here of what that might look like. So I did, instead of doing walnut for the inset panels, I cut those out of maple, and you could do like a little filigree like this if you wanted to have some detail. So you could etch on the surface, definitely. You could put some text on the front, but I kind of did a little throwback to some of my old book nook designs and did a filigree cutout there. So just another option. There will be some blank versions of the panels and also of the globes, so you can fully customize those however you want to. So the last part is just putting the scene together. This is the easy part.
This is the easy part. Wow. Okay.
Yeah.
Is it just layer by layer?
Yeah, pretty much. And I'm trying to think. You could go front to back to front, however you want.
Let's go back to front.
Okay, so they can see.
Yes.
Cool.
Yes. I assume this is the back. Is that right?
Yes. Yep.
And does it matter which side the engraving is on?
Yeah. So I reversed the engraving. That way, the clear, the smooth surface would be facing the front. So for this one, that should be the front.
Got it.
And hopefully they fit. I might have shifted my, there we go.
There it goes.
And there's barbs on that too, so that should hopefully snap.
Oh, wow. You want the satisfying snap.
Yes.
Every time. It goes perfectly flush.
Perfectly flush, and there's little barbs under that to grab. There we go.
There we go.
All right.
A little moment of truth.
Yeah, let's see. Aha!
There you have it.
There it is. Yeah. So we've got the nice glowing around all the edges, and all the etched parts light up. And I think it'll look really cool in the dark.
Yeah, this is a lovely, lovely project. Taking the idea, the parameters of something that is spherical. It's like, how do you replicate the look of something spherical with flat material? But I think you did a really admirable job. And then in your example as well, you did some painting, of course, some extra aestheticizing.
I couldn't help myself. I had to take it a little bit further. So I did a little bit of snow detailing on there. That's just some glue and a little bit of white acrylic paint, and I sprinkled in some faux model snow in there and a little bit of sparkle, and made kind of like little snow drifts. So just add a little bit of an extra touch to the scene, but you can totally customize the globe on the front with your own text, or do the side panels the way that I've done with these. And you can get these files in the Glowforge catalog to make your own at home.
Oh, that's just lovely. Thank you so much, Jen, for bringing this project in and for partnering with Glowforge. So they made this possible. We'll have links for people who may have Glowforges to check out in their catalog. But I certainly learned a lot about the design process, all the trials and learnings and the journey that you went through. And if you want to support you and your future laser cutting endeavors, they can also pick up a laser cutter, a Glowforge, with a link below, and that helps directly support your projects in the future. Yeah,
it's got a code for a certain amount, up to $500, I think, off the purchase of a machine. So if you're interested in getting a Glowforge, I've got one at home. I know Norm uses one too. But yeah, hopefully this has given you some ideas for laser cut designs and for holiday decorating. Thanks so much for watching. Happy holidays.
Bye.